we'll start with derived quantities. Okay, derived quantities. Okay, what are derived quantities? Derived quantities are those quantities that depend on the fundamental quantities for their definition. In other words, we can say that derived quantities are gotten by simple combination of the fundamental quantities. Okay, so we're making a list of the derived quantities we have. Okay, so number one, we have area. Area is a derived quantity. Okay, number two, we have volume. Number three, we have density. Number four, we have width. Number five, we have force. Number six, speed. Number seven, acceleration. I think velocity should have come first. Number eight, velocity. Number nine, work. Number 10, pressure. And order. Okay, energy. Number 11, let's include energy. Okay, so these are the fundamental quantities we have, though we still have some other ones. So what we're going to do right now is to look at their derivations, okay, and of course their units. All these derived quantities have their individual units, that's the derived units. Okay, so we'll go straight into their derivation and their units. All right, okay, welcome back. Number one, area. Area is product of length and breadth. Okay, and the unit is in what? Meter square. That is meter. Length is in meters, breadth in meters. Meters and meter giving us what? Meter square. Okay, good. All right, so number two is volume. Volume is a product of length, breadth, and what? Height. Okay, so length in meters, breadth in meters, height in meters. So we'll have the units what? Meter cube. Remember, the first one is area is meter square, then volume, length times breadth times height, meter cube. Are we okay? Good. Number three, we have density. Density is the ratio of what? It's the ratio of mass to what? Volume. Okay, mass, remember, is a fundamental quantity, is in kg. Volume, meter cube per meter cube. So the unit of density is what? Kg per meter cube. All right, good. Number four, force. Force is the product of mass and what? Acceleration. That's mass times acceleration. Okay, good. Linear acceleration anyway. So force, the unit is in Newton. Okay, brackets N, in brackets capital letter N, is in Newton. Number five, we have weight. Okay. Okay, weight is a product of mass and acceleration due to gravity. Okay, good. So weight, semi-Newton. Okay, the weight can be in ton and some other units, but in physics we'll take it to be Newton. Okay, all right. We have number 6, speed. Speed is a ratio of distance time. Distance is in meters, time seconds. Okay, velocity is displacement, the ratio of displacement to time. Okay, displacement is also in meters. Okay, meters, time, seconds. Remember, time is the fundamental quantity. The unit of time is seconds, so you can see it here. Okay, so speed and velocity, they have the same units. Speed is in meter per second, displacement is in meter per second. Okay, let's quickly do a recap before we go into the other ones. Area is derivation, length times breadth. Okay, and the unit is meter square. Volume, length times breadth times height, meter cube. Density is the ratio of mass to volume. Okay, kg per meter cube. Force, mass times acceleration, unit Newton. Weight, mass times acceleration due to gravity. Okay, Newton. Speed, distance over time, meter per second. Velocity, displacement over time, and unit is what? Meter per second. Okay, number 8, we have acceleration. Acceleration is change in velocity over what? Time. Okay, remember that velocity itself is a meter per second, so altogether with another seconds, that's time. So the unit of acceleration is what? Meter per second square. All right, in our next class, or as we go ahead, I will show us how we got all of these units, like how we came about it. Okay, but I need you to know from the now that acceleration is change in velocity over time, and the unit is what? Meter per second. Are we okay there? Right. Number 9. All right, remember we have momentum. Momentum is the product of mass and what? Velocity. Okay, the unit is kg per meter square. Sorry, kg per meter seconds rather. Mass kg, velocity meter per seconds. Okay, or we can still have it as Newton seconds. And how did we get that? Number 10, it was from the unit of impulse, because impulse is equal to change in moment. Okay, we'll look at that in our next class. All right, impulse is the product of force and time. Okay, force is Newton times seconds. Okay, are we there? Good. All right, number 11, pressure. Pressure is the ratio of force to area. Okay, pressure is in Pascal, the unit Pascal, or force Newton, area per meter square. Either in Pascal or Newton per meter square. Are we okay? Number 12, work. Work is a product of force and what? Distance. Work, the unit is in what? In joule. Okay, or Newton what? Meter. Sorry, Newton meter, right? Newton meter. We have number 13, power. Power is the ratio of work over what? time. Okay, power is in watts. Okay, is in watts. All right, energy, same as this, force and distance. So let's quickly do a recap before we go into something else. Acceleration is change in velocity over time, and the unit is what? Meter per second square. Don't forget. Momentum is a product of mass and velocity. The unit is kg meter per second. Remember this multiplication, this dot here, it indicates multiplication. Okay, or Newton seconds. Okay, impulse is a product of force and time. Force, Newton, time, seconds. Pressure is the ratio of force over area. The unit is Pascal. Okay, and force, Newton, area, meter square. Remember, we've already gotten this, that the unit of area is what? Meter square. Okay, good. Then work, a product of force and distance. Okay, so the unit is in joule anyway, but we can have the unit as force, Newton, distance, meter. Okay, then power, work over time, the unit is what? Watts. Okay, so in the next class, what we're going to go into is dimensions. Okay, dimensions of physical quantities. We're going to look at how what's the relationship between all of these quantities. That's what's the relation that the fundamental quantities have, let me say the relation the three main fundamental quantities have with all of these derived quantities and some other ones. Okay, so we're going to go into the dimensioning of what the physical quantities. All right, remember, you can always pause this video if I'm fast. You can always pause it and let's go back and listen to what I've said previously. Okay, please don't forget to like the video and subscribe to our YouTube channel so that you can be notified of our uploads. Okay, all right, and don't forget also, you can also contact us with the numbers showing on your screen. The numbers showing on your screen, you can always get back to us. Okay, any question at all, any challenge at all, we'll be glad to give you a reply. Okay, thank you so much.